By mid-2025, Meta had integrated Google's Gemini model into the core of its business. It functioned as a 24/7 engine for Facebook and Instagram, automating high-volume content moderation, detecting fraud, and providing coding assistance for thousands of internal engineers. This reliance felt secure because of a 6-year, $10 billion cloud contract Meta had signed with Google. On paper, they had guaranteed access to a virtually limitless pool of server space and intelligence. But that security vanished in March 2026. Google formally notified Meta that it could no longer fulfill the requested Gemini compute capacity, a decision that forced Meta to immediately rethink its entire AI strategy. This chart shows the scale of the restriction. Daily Gemini requests inside Meta plummeted 76%, falling from 5 million to just over 1 million. To manage the shortage, Meta imposed a strict 10,000 query monthly cap on its own software developers. Google's move was a calculated prioritization of its own internal B2B customers. Facing its own infrastructure limits, Google chose to support its primary clients over the external demands of a major competitor. This fallout demonstrated that AI services are not a limitless digital commodity. Meta discovered that even a $10 billion contract cannot procure computing power that physically does not exist. Why did Google run out of room in the first place? To find the answer, we have to look at the physical bottleneck of the AI supply chain. The bottleneck begins with ASML, the only company manufacturing the $300 million lithography systems that etch microscopic circuits onto modern AI chips. This image shows a finished processor, but getting it here requires a specific TSMC process called CoWoS, or advanced packaging. This manufacturing step is currently the primary constraint on global AI chip production. Because TSMC cannot package chips fast enough, NVIDIA's delivery times for the H100 GPU have exceeded 6 months, while prices have climbed toward $55,000 per unit. Even when the hardware is available, data centers require immense resources. A single rack of modern processors can consume 100 kilowatts, roughly the same amount of electricity used by 100 homes. The AI revolution has hit a physical wall made of water, electricity, and silicon. Capacity cannot be expanded simply by signing a larger contract. Meta had the capital to pivot, but other tech companies found that relying on rented cloud compute could be a fatal dependency. Anthropic was forced to delay the launch of Claude Opus 5 by 9 months because Amazon Web Services failed to provide the promised GPU capacity. Midjourney had to temporarily reduce its default image resolution in early 2026 because the computational costs of generating high-definition art had become unsustainable. This timeline tracks the wider industry collapse in early 2026. While some delayed launches, Stability AI faced a total liquidity crisis, accumulating $96 million in cloud debt that eventually forced an emergency sale to Cohere. Relying on rented infrastructure has shifted from a standard business practice to a significant operational risk. Mark Zuckerberg's response was to exit the GPU bidding war entirely. Instead of trying to buy more processors, Meta focused on building a model that required far fewer of them. The result was Muse Spark. It is a proprietary model built for efficiency, designed to deliver high-tier performance with significantly lower power consumption. Meta's thought compression trains the AI to reach correct answers using fewer tokens, delivering results with 10 times less compute. Efficiency is boosted by a mixture of experts architecture, which activates only a small fraction of the network per task, leaving the rest inactive. By matching the performance of much larger models with a fraction of the hardware, Meta turned a supply shortage into a strategic software advantage. Today, Muse Spark handles the majority of Meta's internal operations. But unlike the previous Llama models, Meta is keeping this code strictly proprietary to maintain its competitive edge. Other giants are making similar moves to secure their own infrastructure. Amazon and Apple are developing dedicated chips and exclusive data centers to ensure they never have to rely on a competitor's capacity again. Dr. Jan LeCun argues that physical hardware has become the ultimate strategic bottleneck, meaning even the most advanced algorithm is useless if you lack the processor capacity to run it. This shortage is creating a structural divide in the tech economy. While companies like Amazon and Apple insulate themselves with proprietary chips and private data centers, those who rely on external APIs find their growth entirely dependent on their suppliers' capacity limits.